right. 1.2, intercept symmetry, graphing key equations. All right, procedure for finding intercepts. Most of you guys already know this. All right, to find the x-intercepts, plug in 0 for y, and then you just solve for x. To find the y-intercepts, plug in 0 for x, and then you just solve for y. So for example, find the x-intercepts and the y-intercepts of this graph, then graph the equation by plotting points. So we have y equals x squared minus 4. Excuse me. To find the x-intercepts, I'm going to plug in 0 for y. So let me change colors. Let's use red. Plug in 0 for y. Now, if you guys remember from algebra, this is a difference of two squares. The difference of two squares equation was a squared minus b squared. You can factor it like this. A plus b, a minus b. This comes in handy. Okay, so I'm going to rewrite this. X squared minus 4 equals 0. This factors into x plus 2 times x minus 2. So I've got x plus 2 equals 0. X minus 2 equals 0. Subtract 2 from each side. X equals negative 2. Add 2 to each side. X equals positive 2. So the x-intercepts are negative 2, 0, and 2, 0. So now let's find the y-intercepts. To find the y-intercept, you just plug in 0 for x. So I've got y equals x squared minus 4. I'm going to plug in 0 for x. So I got y equals 0 squared, minus 4. Y equals negative 4. So the y-intercept is 0, negative 4. So now I can graph this. Close enough. So I've got negative 2, 0, 2, 0, and 0, negative 4. And I know it's a parabola, so it's going to look something kind of like that. Alright? Okay, you guys can try the other problem. Okay, I'm going to write these in for a sec. Alright. A graph is said to be symmetric with respect to, the WRT stands for with respect to, the x-axis, if for every point x, y on the graph, the point x negative y is also on the graph. So for example, this is the graph of x equals y squared. Every point up here is reflected down here. So every xy is x negative y down here. A graph is said to be symmetric with respect to the y-axis if for every point xy on the graph, the point negative xy is also on the graph. So this is the graph of y equals x squared. So every point over here is reflected over here. Every xy is a negative xy over here. A graph is said to be symmetric with respect to the origin if for every point xy on the graph, the point negative x negative y is also on the graph. So this is the graph of y equals x cubed. Every point up here reflected down here. So xy becomes negative x negative y down here. Okay, this example, there really isn't anything to do, just to read it. If a graph is symmetric with respect to the x-axis and the point 4, 2 is on the graph, then you know automatically 4, negative 2 is also on the graph. If a graph is symmetric to with respect to the y-axis and the point 4, 2 is on the graph, then the point negative 4, 2 is also on the graph. If the graph is symmetric with respect to the origin and the point 4, 2 is on the graph, then the point negative 4, negative 2 is also on the graph. Okay? So, using this example, you guys go ahead and try this one. Okay. Tests for symmetry. To test the graph of an equation for symmetry with respect to the x-axis, replace y with negative y, and then see if you get an equation that's the same thing. With the y-axis, replace x with negative x and see if you get the same thing. With respect to the origin, replace x and y with negative x and negative y, and see if you get an equivalent equation. Okay, example 3. For the equation x squared minus 4 over x squared plus 1, find the intercepts and test for symmetry. Okay, so they didn't really put the y in there. I think that's probably a mistake on my part. There should be a y equals. So y equals x squared minus 4 over x squared plus 1. To find the intercepts, first thing, I'm going to find let's find the y-intercept first. I'm going to plug in 0 for x. So I've got y equals 0 squared minus 4 over 0 squared plus 1, which is negative 4 over 1, which is negative 4. So my y-intercept is 0, negative 4. Okay, now let's do the same thing for x. Change colors. And red. So 0 equals x squared minus 4 over x squared plus 1. Alright, I'm going to multiply both sides by the denominator. So I have 0 equals x squared minus 4. This, once again, is a difference of two squares, so I've got x plus 2, x minus 2 equals 0. X plus 2 equals 0. X minus 2 equals 0. I'm going to subtract 2 from both sides. X equals negative 2. Then I'm going to add 2 to both sides. X equals positive 2. So the x-intercepts are 2, 0, and negative 2, 0. So I found the intercepts. Now I need to test for symmetry. I'm going to go over here. So, to test for symmetry about the x-axis, I'm going to replace y with a negative y. If I multiply both sides by negative 1, I end up with y equals negative x squared plus 4 over x squared plus 1. Okay, this does not equal this, so it is not symmetric with respect to the x-axis. Let's try the y-axis. So, got this. Going to plug in negative x to everywhere I see an x. Negative x squared is just x squared, because the negative 1 squared is just a positive 1. This does equal this, so it is symmetric with respect to the y-axis. Okay? Alright, you guys can try this. Okay, graph the equation y equals x cubed by hand by plotting points. Find any intercepts and check for symmetry first. Alright, let's look for intercepts first. Y equals x cubed. I'm going to plug in 0 for y. 0, 0. You take the cube root, both sides, x equals 0. And if you plug in 0 for x, voila, you get y equals 0. So, here is our one intercept. Oop. Our one intercept. Okay? Symmetry. If we want to test to see if it's symmetric with respect to the x-axis, I'm going to plug in a negative y here. Nope. Let's plug in a negative x. Nope. Let's plug in negative x and negative y. There we go. It is symmetric with respect to the origin. Okay, so now when we graph it, we know it hits 0, 0. and we know it's going to be symmetric diagonally. So let's go ahead and plot some points. Let's plot -2, -1, 0, 1, and 2. 0 we already know is 0. If you plug in -2, let's see here. How much more space do I have? -2 cubed is -8. -1 cubed is -1. 1 cubed is 1. 2 cubed is 8. Okay, so let's go ahead and plot these. -2, -8. Okay, 1, or -1, -1. 1, 1. 1, 2, 3, 4, 5, 6, 8, and 2, 8. Okay, so it looks like it goes something like this. That is the graph of x cubed. Alright, graph the equation x equals y squared. Find any intercepts and check for symmetry first. Alright, intercepts, let's plug in 0 for x. I'll write the equation first. X equals y squared, so 0 equals y squared. We're going to have 0. 0, 0 again. You guys can go ahead, if you want, you can go ahead and plug in 0 for y also. But you can kind of see this is our one intercept once again. Okay. Is it symmetric with respect to the x-axis? Let's find out. I'm going to plug in -y. -y squared is just y squared, so it is in fact symmetric with respect to the x-axis. Okay, so let's go ahead and graph this. Actually, I'm going to graph it a little bit over here. I'm going to go ahead and plot some points. Let's do 0, 1, and 2. 0 we already know is 0. So for 1, actually, let me do 4 instead, just because I already know what the graph kind of looks like. If you plug in 1 for x, take the square root of both sides. Y equals positive -1. Okay. Plug in 4 for x. Y equals positive -2. So we actually have 5 points here. We have the point 0, 0. We have 1 positive 1, 1 -1, and 4, 1, 2, 3, 4, positive 2, and 4, -2. So the graph looks something like this. Okay. Alright, graph the equation y equals 1 over x, find any intercept, blah, blah, blah. Let's do the same thing. So I'm going to plug in 0 for x. Now, hopefully you guys know you cannot have a 0 in the denominator. This is undefined. Okay? Because if you think about it, how many times does 0 go into 1? you can add 0 plus 0 plus 0 plus 0 plus 0 for forever, and you would never get to 1. That's why it's undefined. You can't have a 0 in the